Welcome to True Projects. In this video, we are going to explain about the project which is improving 1 year mortality prediction after pediatric heart transplantation using hypothetical donor recipient matches. So, before getting into the execution, first let's understand what is the project about. Heart transplantation. It's a crucial procedure for children with end stage heart failure, offering them a chance at a new life. While pediatric heart transplants account for only 10% of all transplants, the number have been steadily increasing with over 450 performed in the US in 2020. Despite advancements in care, the 1 year post transplant mortality rates remain high, which is concerning for families and healthcare providers. Additionally, waitlist mortality is a significant issue due to the limited availability of donor organs, with many potential organs often being rejected. Overall, while progress is being made, there are still significant challenges in ensuring that all children in need receive the life saving transplants they require. When it comes to organ allocation for heart transplants, we often use predictive models like heart transplantation survival score, that is HTTS, and the Eurotransplant Donor Risk Index, that is ETDRI. While these tools help us guiding decisions, they rely on traditional statistical methods, and they often struggle with the complex nonlinear relationship between donor and recipient factors. In pediatric cases, the challenges are even greater. We typically deal with the smaller sample sizes, varying practices across different transplant centers, and shifting policies, which can limit the accuracy and generalizability of these models. This highlights the need for more advanced predictive tools that can better manage the variability in medical data and improve decision making for pediatric heart transplants. So, there is need for more advanced predictive tools to predict this 1 year mortality. So, to address the challenges in predicting post transplantation mortality of pediatric heart transplant recipients, we are proposing a chi-square feature selection technique. So in this project, we'll be using chi-square to select the important features. This method identifies the most relevant donor and recipient factors, which helps simplify the data and enhances the model efficiency. And here we have also incorporated k nearest neighbor, which is the semi-supervised learning technique. So initially, this model is trained on the label data from the actual donor recipient pairs to predict the likelihood of mortality within 1 year after the transplantation. To validate the effectiveness of our model, we have used the real world data from UNOS. So we have used UNOS database. This validation ensures that our approach reliability predict outcomes for children undergoing heart transplants. By improving prediction accuracy, we aim to enhance decision making process in organ allocation, ultimately leading to better survival rates for pediatric heart transplant recipients. Moving on, to further improve the performance, in this project we are incorporating an ensemble based method. This involves combining the outputs of multiple individual models in a single model. So in this project we'll be implementing voting classifier in which we have combined multiple models which are boosting decision tree and extra tree algorithms. So in the voting classifier we are combining these two algorithms. So by doing this, we aim to create a final prediction that not only more robust but also more accurate. In fact, this approach ended up with achieving highest accuracy compared to all the other models we tested. On top of that, we have developed front-end using Flash framework. So we have developed front-end using Flash framework. This interface is designed to make it easier for users to interact with the system during testing, to ensure that the data is secure and the different users can access the system appropriately. We included user authentication features. This way we can manage who gets to see and use the application while keeping everything secure. Moving on to algorithms used, these are the algorithms used in the project. So this is the proposed model. We have used these two for the comparison. And the last model is the extension model. So this has outperformed the other model. So we have used it for deploying. So this model will be used for predicting the 1 year mortality post transplantation of heart. Moving on, how did we implement the project is we have followed these steps. So let's understand them. The first step is importing the packages. So first we have imported the packages, then we have explored the heart transplant data, heart transplant expired data for understanding structure of the data. Then we have processed the data, we have cleaned the data, we dropped unwanted columns and also the null values that are nothing but missing values. Then we visualized it using correlation matrix, which shows the correlation between the variables and the sample outcome. Coming to sample outcome, it shows the distribution of the each class. Then we have converted categorical data into numerical using label encoding technique. And then we'll be appending all the features to X variable and target to Y variable. Then we select important features using filter method, which is chi-square. Then we split the data into train and test sets. Train is used to train the models and test is used to evaluate the models. Then we build the models. We have built KNN model and random forest linear regression multiple models. So those models, they are hyperparameter tuned using grid search CV. Then we fit it with the data set, that is with the training data set, and then we evaluate those models using accuracy, precision, recall, FN score. And then we compare them using graphs. And we have developed front end using Flask framework, which is integrated with the SQLite database. And in the front end, users, they will be able to give the feature values. That feature values will be pre-processed at the back end and it will be fit with the train model. Finally, the train model will give the prediction that whether patient will die or survive. Moving on, we need hardware and software requirements to implement this project. So coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let's execute. So open the code folder which contains source code files. So these are the source code files in the code folder of the project. In the first static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Coming to templates, this contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And in this app.py file, this file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here in this ICUDF file, we have the dataset used in the project. It's buffering, it is loading. So this is the dataset that is used in this project to predict the 1-year mortality of post heart transplantation. So we will be using this data set and we will be selecting important features from that and we will build the models with this data set. Let's close this. This is the model file which contain the algorithm information and this will be loaded into the project code during runtime of the application. And this is the notebook file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And next we have a signup.db file. This file is a database file which is used to store the user information. And here in the sample file, we have the test cases. So let's open it. That we will be using it in the front end to predict. So these are the test cases. We will be using them to predict it in the front end. So let's close this. Now let's execute. To execute, copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. So Anaconda prompt is open. Now type the command cd followed by the space, paste the copied path. Now click on enter. So this will change current directory to the code folder's path. Now compile app.py file. So I'm giving the command python space app.py. Now click on enter. This command will execute the Python script and perform runtime check and perform the runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. Now let's copy this local link provided by the Flask framework and paste it into any web browser. So copy the link. I prefer Google Chrome, so I will paste it in that. Paste the link here. At the end, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to register first. So click on register. If you are new users, you need to fill in all these details for the registration. I have already registered, so I'll directly log in. So click on sign in. So give the username and the password. So I'm giving my username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page of the project. So these are the parameters which are supposed to be given for the prediction purpose. Let's understand each of the parameter and then let's enter the input. So first we have is level 0. It refers to the patient's clinical status or the severity of illness, which can be categorized into different stages or levels. Coming to respirate max, it is a maximum recorded respiratory rate indicating the highest number of breaths per minute during monitoring. Coming to respirate mean, it is the average respiratory rate calculated over a specific period reflecting the overall breathing pattern. Coming to lactate max, so this is the highest lactate level recorded, which can indicate the severity of tissue hypoxia or metabolic distress. Coming to PO2 max, it is the maximum level of oxygen partial pressure in the blood, showing the highest oxygen saturation during monitoring. Coming to lactate min, it is the lowest recorded lactate level, which can signify improved metabolic function or reduced tissue hypoxia. Coming to lactate min labs, it is the minimum lactate level obtained from laboratory tests used for precise monitoring of metabolic status. Next one is lactate max labs. It is the maximum lactate level obtained from laboratory tests crucial for assessing the severity of lactate acidosis. Coming to PTT min. PTT min, it is the minimum value of the activated partial thromoplasm time, that is PTT, indicating the shortest time for blood to clot. PTT max. It is the maximum value of the activated partial thromboplastin time, that is PTT, indicating the longest time for blood to clot. Coming to Bunmin, it is the minimum blood urea nitrogen level which helps assess kidney function. Coming to Bunmax, Bunmax is the blood urea nitrogen level which can indicate kidney impairment or dehydration. It is the maximum blood urea nitrogen. Coming to GISIS, it's a score of measure related to Glasgow Coma Scale, that is called GCS, for eye response, assessing the patient's level of consciousness. Coming to RESPXVENT, it is a parameter that indicates the use of ventilator and respiratory support provided to the patient. Coming to the last value, that is index, it is a calculated value or a score that aggregates specific clinical parameters often used for risk stratification or decision making in patient care. So it is a risk stratification or decision making in patient care. So now let's enter all these parameters. So those we have in the sample file in the code folder. Let's open that. So this is a sample file. So these are the inputs to be given. Let's enter them. So the first value should be given as level 0. So let's copy it. The next one we have is respiratory max. So let's copy that. Respiratory mean, lactate max, PO2 max, lactate min, lactate min labs, lactate max labs, PTT min, and next we are supposed to enter is PTT max. We have copied the same number. This has to be copied. Next is bun max. Copy it. paste it. Next is bun max. Next we are supposed to enter is GCA size. The next one is respects went. The last one we have is index number. So now click on predict. Here we got the prediction that patient will die after 1 year of heart transplantation. So based on the given input, if the patient will be transplanted with the heart, he will die after 1 year. So let's try with the other test case. So click on prediction. Here we need to give in all these parameters. So let's give them. So I have entered all the parameters. Now let's click on predict. So click on predict. Here we got the prediction that patient will be alive after 1 year of heart transplantation, which means that even though if a patient has been transplanted with the heart, he will be alive after 1 year. Now let's try using one more test case. So click on prediction. So I have entered all the parameters. Now let's click on predict. So click on predict. And here we got the prediction that patient will die after 1 year of heart transplantation. If it means that if a patient is transplanted with the heart, he will be dying after 1 year. So let's check with the graphs of the project. So click on graph. Here we have the sample outcome graph where on x-axis we have the target variable and on y-axis we have the count of each target. Moving on, this is the correlation matrix which shows the correlation between the two variables. And here we have accuracy comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithm names. And here we have precision score comparison graph. This is recall score. And here we have all these graphs. Now click on logout. In this way, by using machine learning models, we will be able to accurately predict the 1 year post transplantation of risk of the patient. That means whether he will die or he will not die. We will be able to correctly predict the mortality of that patient. So this is all about the project.
TrueProjects.in For updates on latest project videos, please visit TrueProjects YouTube channel and subscribe.